Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our upcoming videos, subscribe to the channel and activate the bell to receive all notifications. There's a mystery looming at the edges of our solar system, a cosmic enigma that has intrigued astronomers for years, fueled scientists' curiosity, and sparked the imagination of those who gaze at the sky with eyes full of questions. The hypothesis of the existence of a ninth planet, a remote, icy giant that still escapes direct observation but leaves indelible gravitational traces on the behavior of other celestial bodies, continues to stimulate collective imagination. This object, nicknamed Planet 9, represents one of the most fascinating and controversial astronomical theories of the last decade, a possibility that, if confirmed, would rewrite our understanding of the solar system's structure and its evolution. The story of Planet 9 gained momentum in 2016, when two Caltech astrophysicists, Mike Brown and Konstantin Batygin, published a paper that shook the scientific community. Brown, known for his role in Pluto's reclassification to dwarf planet, and Batygin, examined the orbits of 14 extreme trans-Neptunian objects located well beyond Neptune's orbit. These icy and distant bodies shared a surprising orbital consistency, as if an enormous invisible mass were uniformly influencing their movements. The likelihood that this alignment was random was so low that the two scientists hypothesized the presence of a new and unknown planet. The proposed theory suggested that Planet 9 has a mass about 6.2 times that of Earth and is located between 300 and 520 astronomical units, from the Sun. That is, between 45 and 78 billion kilometers. This distance is extremely far compared to known planets, with Planet 9's orbit potentially extending well beyond Neptune's. However, this theory has faced criticism and, while fascinating, the direct search for such a distant object has proven extremely complex. Looking for an object so far away is like searching for a grain of sand in an ocean. The sunlight reaching the planet would be extremely faint, making its visibility nearly impossible with traditional optical telescopes. However, astronomy has made huge advances thanks to more sophisticated tools, such as infrared telescopes, which can detect radiation emitted by celestial bodies, even the most distant and cold. Infrared radiation, in fact, is a form of energy not dependent on sunlight but emitted by bodies based on their residual heat. This radiation can even penetrate dense clouds of cosmic dust, allowing observation of very distant objects. In 2021, a bold new study was conducted by Terry Longpan from Tsinghua University in Taiwan, in collaboration with a team of Japanese and Taiwanese astronomers. These scientists decided to explore historical data, dusting off archives from the IRAS Infrared Astronomical Satellite mission, launched in 1983, and Akari, a Japanese space telescope active since 2006. The idea behind the research was quite simple. Compare sky maps obtained by these satellites over 20 years apart to identify infrared sources that showed spatial displacement, a possible sign of an object in orbit. The advantage of infrared is that this radiation is not only directly emitted by celestial bodies in the form of heat, but it can also be detected from great distances, much farther than is possible with visible light. Moreover, infrared radiation diminishes only with the square of the distance, meaning even extremely distant objects can be detected, albeit faintly. The data analysis was incredibly complex. Researchers had to examine thousands of infrared sources, eliminating those that were too bright or located too close to the plane of the Milky Way, where stellar density makes it difficult to distinguish faint objects. After careful selection, some suspicious sources emerged that seemed compatible with theoretical predictions related to Planet 9. Although the work is still in preprint, thus not yet peer-reviewed, the analysis has sparked great interest in the scientific community. The possibility of observing a real signal linked to Planet 9 is now more concrete than ever. If one of these sources turns out to be Planet 9, the discovery would mark one of the most significant moments in modern astronomical history. Its importance would be comparable to the discovery of Neptune in 1846, which was initially predicted only through the gravitational effects it had on other planets. However, the challenge of identifying Planet 9 is even greater, mainly for two reasons: the distance involved and the nature of its orbit. It is believed that Planet the 9th of may have an orbit extremely tilted relative to the ecliptic plane, the plane on which most solar system planets orbit. This inclination could make its position even harder to predict, increasing the difficulty of locating it. Furthermore, the object may currently be in a very distant position from Earth, making it practically invisible even to the most sensitive telescopes. Despite the difficulties, the hunt for Planet 9 is not stopping. More powerful instruments, like the James Webb Space Telescope, are capable of observing the cold and distant universe with unprecedented precision. In addition, the upcoming Vera C. Rubin Observatory, which will monitor the entire visible sky every few nights, could provide the crucial data to finally confirm or deny the existence of this mysterious world. Advanced technology, combined with innovative methods such as historical data analysis, continues to push research in new directions. Beyond the discovery itself, what Planet 9 represents is a symbol of our tireless desire to explore the unknown. Its existence, which could be confirmed or refuted in the coming years, has already had the merit of renewing interest in the remote boundaries of our solar system. The theory of a ninth planet has driven a new generation of astronomers, engineers, and dreamers to go beyond known limits and to question what lies beyond the visible horizon. If its existence were confirmed, Planet 9 would not only enrich our understanding of the structure and evolution of the solar system, but could also lead to new theories about how planets form and about the existence of similar objects in other distant star systems. And who knows, perhaps one day, among the billions of stars crowding the sky, one of those seemingly insignificant dots hides an entire world, still unknown, just waiting to be discovered. In any case, the mystery of Planet 9 invites us to look up at the sky with curious eyes and full of questions, ready to write the next chapter of a story that, though still unfolding, has already inspired generations of scientists and astronomy enthusiasts.